So hello, thanks for clicking this video and checking me out. Um, we're gonna start off with when it comes to data types, we're gonna start with integers because they're a little bit more complex in a way. For example, let me show you var x int equals 8, right? And then we put x here. This is a simple way to do it, but when it comes to integers, you can also do 8, right? And then you can do 16, and then 32, and then 64, you can do that. And basically what that is just showing, increasing the amount of space that the integer can take, and also the range that it goes. So this is signed, so that means it allows it to take in negative numbers. So this can be -8, but realistically for 8 we can do 8 int 8, right? And this is the range -128 through 127. And if I do uint, it's gonna be, and I put 255, it's through 0 through 255. But when I go to 256, there's gonna be a problem. We have to bring it back up to uint 16. But you don't need to do this. You could literally just do this, right? And make life easy. But if you want to be memory efficient, then you only really need to use as much as you have to, which would make you have to do var x int 16, I believe. No, int 32. So in this case, you can use int 32 and you're ready to go. Now, because this is positive, it would be more accurate to do uint 32. And yeah, or maybe even 16. No, 32. The range for 16 is, yeah, this is 100,000 and that is 65.5. So you would need to do 32. Now, it kind of works the same way for floats. Float 32. It's just that you're limited to only float 32 and float 64. Again, the higher you go, the more memory it takes. So if you want to be memory efficient, you go with the low as possible. And yeah, so we can just forget about that. And go on to something else. Maybe arrays. So let's go with this long array. Um, Equals. Let's just go with 5. And you put the type after. So you put the amount you want, the amount of elements, and then you put the type after. And then you do this. Put some curly brackets. And you do 1, 2, 3, 4, 5. And it wants to be put here. So let's do that. Yeah, so it would print 1, 2, 3, 4, 5. Normally I would print, but you get the idea. There's no errors that show up. So now if you want to make a slice, an easy way to make a slice is to just copy the values. Like for example, short slice equals long array 0 to 3. And then you just do this. And bam. Yeah. So there you go. That's your arrays and your slices. For booleans, it works the same way. Bool, no. Var is valid bool. So the keyword var comes before the name and then the type comes here. I'm a little bit late, but yeah, true. And then if I were to put it here, sorry about that, you have this. It's gonna print it all out soon enough. Let's just, okay. So next on the list, we have structs. Now, this is similar to a dictionary in Python. You have your struct, cat struct. Let's just make it, call it cat. And we do name, string, age, uint 8. And here we can see a name would be a string, and the age would be uint 8. So it's like unsigned 8-bit integers, 0 through 255. So this is the lowest amount of memory this can possibly take. So we're being efficient here. And that's about it, to be honest. A cat can't possibly be over the age of 255. It's impossible. So here we can do C equals, okay, let's do cat name and age equals cat curly brackets. Let's just do Jesse and 9, because cats have 9 lives. And we can just copy this. There we go. And I'm missing this. So yeah, and if you look at it, it's var. If I take this out, it would be var, right? So we're just making life a little bit easier for ourselves by just sticking to using this. So there it is. And as for the pointers data type, an example of using pointers is like, let's say I want to do this. Name equals Jack. And I want to add a last name to it, right? I want to add a last name. So I create a function called func add last name. Now, I may not be as precise as possible because pointers can be kind of funny to deal with. But this is my understanding. You can create a parameter called name ptr, so name pointer, and you use the asterisk before the data type, which is string, and it creates a new data type. And you we kind of have a comparison here. So if you want to change the value of name itself, you do that by changing the value of the thing, that thing's address. So it's like name pointer equals name plus hill. So we're adding hill as the last name, right? So we just input um add last name name. Actually, since this is the first argument, we put the address of name here so that it can change the value of the this is the new value. So we change the value of name, right? We change the value of name by changing whatever is at the address. So this is the address, the memory address, the RAM address, right? And it changes the last name. So let's just add a space, and we can print out name. Now correct me if I'm wrong, this might not be perfect because I don't have a perfect understanding of pointers. I'm actually coming from Python into Go, even though I've been coding Go for a decently long time. So yeah, and we can print this out. Let's just clear this out. Go run hello.go. Now you might need to skip because this might take a little bit of time, but let's just see what it prints out, and we can discuss what it prints out once it's done. Okay, so the long array, we printed it out, and it's that 1 2 3. That's the slice we created for. It's basically a copy. um True is valid. Jesse 9, that's the cat struct we created, which is basically like a dictionary in Python. Jack Hill, name Jack, add last name. So we change the value. Hold on, let me try something. Actually, never mind. Yeah, that's about it though. There we go. Thank you for watching this video.